And good afternoon, everybody, and welcome to our third and final sector. This is a focus on the energy sector, and with me today is our subject matter expert, Joe Weiss, an engineer out in California. And Joe, I do thank you so very much for coming on the channel today, because what we're going to be talking about is very important. By the way, my name, just for review, Joe Concannon, the president of Integris Security. And, I have a past also in the InfraGard program here in New York City. So these issues, when we get to national security issues, these are things which gets me very focused and very energized very quickly. All right. The threats that we see in software development and in network appliances and things of that nature. These are things that we've been discussing for years. They've been out there for a very, very long time. I call it the data breach du jour, all right, of the day, because there are just so many of them these days, and we've been discussing them for a long while. Sometimes it gets very frustrating to a lot of people out there because they say, well, if this has been happening for so long, how come we aren't fixing it? All right. So with that, I want to sort of navigate over to the threats. The threats are our national security threats, and we started the InfraGard program in New York under Presidential Decision Directive 63, which was President Clinton at that time. We focused on 16 to 18 different industry sectors. All right, as we went through, energy is one of them. The energy sector is an industrial sector, and it's one that is kind of stoic. All right. The people who have been in them for quite some time. All right. And they know what the real problems and the issues are behind the scenes. It's not always about the network and the software. All right. But it is about the control systems. And that's why Joe is on with us today, because he knows control systems, has written about it, published about it, like the back of his hand. He knows about it. And he's also a leader in the industry. As he mentioned in the previous sector, he sits on many national and international boards in regards to all of this. So Joe, we discussed 13-920, that presidential emergency executive order. And we went into the definitions a little bit, just to give some people's who are listening some structure, context of what we're talking about. All right. So now bring it home for us, because this becomes something that we really want to think about and hear about. And I'm not going to give the prize away here. This is for you to talk about, since you are the subject matter expert. Tell us, about these transformers and the executive order, and how it is impacting us here in New York and perhaps nationally across the country. Take it away, Joe.
Thanks. I'm going to start with a little bit of history before I go into the transformers. And it's one that you directly were affected by. It's called the 2003 Northeast outage. Okay. The 2003 Northeast outage was caused by two things: a tree falling on a power line, but the other was a SCADA system at a utility that had a known software bug that if there were too many alarms, it locked out and it had no alarms. And what happened with the 2003 Northeast outage, this is almost a precursor to Stuxnet in terms of what they did.
Yeah, I kind of remember it. Yeah.
So what happened was, when the tree fell on the line, it started tripping off all kinds of systems down the line. It tripped off so many that the control center at First Energy, which was kind of the hub of where all of this was going, showed no alarms. And so the SCADA operator was getting phone calls from all around him saying the system is falling apart. The SCADA operator looked at his screens and said, no, it isn't. I have no alarms, and ignored it. Now, if you looked at the final report of the Northeast outage signed by the US Secretary of Energy and his Canadian counterpart, a quarter to a third of the recommendations of the 2003 Northeast outage were cyber. Surprise, surprise. Okay. So the first thing you would ask, how does this bring it home? Think about everybody in New York during the 2003 Northeast outage. And that was only a couple of days. Okay. Why? There was no equipment damaged. This is, in a sense, like when I talked before about, in the previous segment, about a cyber incident. This would be a trivial one. There was no damage. You know, if you will, almost like a data breach in a funny sense.
Right.
Now, what a transformer does, let me kind of take you through this for a minute. A transformer is there to either step up, increase voltage, or decrease voltage. So if you don't have the transformer, you're not going to get voltage to your house, to your business, to anything else. So it starts with at a plant, power plant of whatever kind, where it's generating the voltage, it goes to the transformer and it's what's called steps it up to say 230,000 volts or 500,000 volts or whatever it is, to put it on these really big power lines that you see, these big steel transmission lines. Well, as you're transmitting the electricity, there are losses. I mean, heat, da-da-da-da-da-da. So every so often you're going to have substations. What are they going to do? You're going to have transformers in there to boost the voltage back up. Well, when you get near where you're going to use it, you have to take that, say, 230,000 volts and drop it down to 100,000 volts to 60,000 volts, you know, to 16,000 volts, all the way down to, you know, 440 or 220 or 110.
Right.
Okay.
Yeah.
Well,
I get.
in each of those places, the way that's done is via the transformers. So if those transformers have a problem, you can't get from point A where it's generated to point B where it's used. Period. That's why they're so important. Okay.
Okay.
Now, and by the way, it doesn't matter how the voltage is generated. I was at a utility scale solar plant. What did it have? I mean, to give you an idea of, also, I brought up IoT, Internet of Things. This was roughly, I think it was a 150 megawatt solar plant. It was just solar cells everywhere. To give you an idea how big this was, there were over 2 million solar panels in this 150 megawatt solar farm. This is the size, if you will, of a small coal plant. Okay. And where was it all going? To a transformer to put onto the grid.
Right.
So what I'm trying to say is, I don't care if it's the old grid or the new grid.
Right.
Some of these Chinese transformers are now in wind farms. So it's prevalent everywhere.
Right.
Okay. The concern is, like I say, if you damage the transformer, or for that matter, a generator or this large stuff you can't buy at Home Depot, you can be out for months and months or years. The other problem we have is it isn't just the transformers. All of industrial equipment, in order to run efficiently, is running close to, if you will, their limits of where they could be, you know, they could break. Okay. The closer you are, the more efficient it is.
Uh-huh.
Which is why safety becomes such a big problem. Okay. Well, there was a demonstration done in 2007 at the Idaho National Lab called Aurora. And what it did is it simply took a known problem, which to any electrical engineer that taught freshman year, you never restart alternating current equipment. In other words, where you have this 60 cycle sine wave out of phase with a grid, because if those sine waves don't line up, Mother Nature will create a large torque and large current spike. Mother Nature will break it on its own.
Wow.
No malware, nothing. This is just simply Mother Nature. What the Idaho test was about was, gee, can you do this intentionally? The answer was yes. Do China, Russia, Iran, North Korea, et cetera, know? Sure they do. Got the same equipment. You know, people are taught the same electrical engineering. Okay.
Right.
This type of problem, of which there's no malware involved. Excuse me. Andy Greenberg from Wired wrote an article that took only 30 lines of code to destroy this 27-ton generator. He was wrong. It took 0 lines of code to destroy the 27-ton generator. All it was simply, and by the way, the Russians, it's 2 steps. It's simply, if you will, opening a breaker like in your fuse box at home, which turns off the power, and then reopening it, but reopening it out of phase. If you reopen it out of phase,
Everything goes haywire.
not just haywire, it breaks things. Period. No ifs, ands, or buts, period. This is part of the reason one of our biggest problems in cybersecurity is the engineers who understand what's actually going on are often kept out of the cybersecurity discussions or issues by the network people who don't understand any of the physics. We can't get there from here.
Wow.
Period. This was part of when I gave that June 9th presentation to the New York State Cybersecurity Conference.
Yeah, no, I remember. Yep.
That if you think about it, it's like saying you don't want the doctor, doing the heart bypass, have the network person do it because they're the ones who put in the network into the operating room. That sounds silly.
Yeah, I know.
Well, what are you doing with the electric grid?
Same
You brought
thing.
on all these people who've never run a power plant, a substation, or anything else, many of them who've never even seen any of this equipment. And that includes many of the CISOs, the Chief Information Security Officers. Their purview is not a pump, a valve, or a relay. Their purview is the network.
Right.
Well, what are you having them responsible for? Or conversely, why is the vice president of power production or power delivery not even on any of these cyber teams? That's completely and totally broken.
Well, I don't disagree with you on any of those points, but I want you to get into these transformers though, and I want you to unveil the national security issue, starting with New York, and what our true vulnerability is. Joe, when we talk about vulnerabilities, whether it's InfraGard or with my private company, Integra Security, we're talking about passwords and we're talking about network devices. We're talking about, how the architecture has been put together and all sorts of various different components, policies, procedures, and practices and things of that nature. All right. But we're not getting to where you're going to go next. So go into that a little bit.
Okay. In the substation, you've got transformers, you've got other pieces of equipment. You will have networks there, and the networks will have servers that have what you brought up, where you need passwords, where you need, user ID. Why? Because you've got, traditional internet protocol networks to take data.
Right.
What apparently, and I have to use the word apparently because nobody's ever come out and officially said what was found in the Chinese transformers. But when you read between the lines, what's in 13.920, what has to happen, and where the electronics were put, they weren't on the network. So there is no password, there's no user IDs or anything else.
Right.
What this thing is set up to do, as best as I know, and I need to make sure people understand, DOE has not published anything publicly to anybody on what has been found in the transformer at Sandia or what was found at the transformer at WAPA.
Well, I'll say this. I'm glad they really haven't, to a certain degree. Because I don't know that I'd want that information out around the nation. And because if it gets out of the box, then everybody's going to have it.
Well, here's the issue. It's one thing not to have it in the New York Times or the Washington Post. It's another thing when Con Ed and PSE&G, I'm saying from your neck of the woods, et cetera, are not even told what's in there.
Well, you've hit the other side of it. You're absolutely right about that.
Okay.
They should be brought into briefings and told what's going on.
That is the point.
Right.
And because of that, you've had this pushback from industry that it isn't real. Okay. This is not to say, I remember when I was writing my book, it was, how do I educate the good guys without educating the bad guys?
Right.
It's very difficult.
Right.
The point being, like I say, without being flippant, this doesn't need to be put in the open literature. But it's another thing when the operator of that plant or substation is not being told anything.
Right. And he's kept totally in the dark. No,
So
I get you. So get into what could possibly be one of our biggest vulnerabilities in New York State.
So here's the thing. The grid is interconnected. They depend on, I mentioned how the transformers work. So the transformers feed from substation to substation.
Right.
Well, you may be going from NYPA to New York State Electric and Gas, or to Orange and Rockland, or to Con Ed. I mean, as you're trying to get, power from Niagara down into New York City.
Right.
Or from, say, some of the plants in New Jersey into New York City.
Okay.
So you're talking about the fact that they're connected to each other. The designs and everything else have been based on the transformers working properly, or even if they're out, they fail and everything is, you work around them. If what I believe and others believe, that the Chinese have this backdoor where they can send in spoof signals. In other words, so it's not the voltage signal you think it's getting, it's a lower or higher voltage. The transformer isn't going to ask if it's correct or where it came from. That equipment, being taking a load tap changer, that's what, if you will, raises or lowers the voltage. Well, the grid is based on that voltage being a particular voltage. That's also why you have the tap changers in there, to be able to make sure that voltage is where it's supposed to be.
Right.
So one of the things that there's a concern about is if the Chinese get to one of these transformers at utility A, they can affect utility B. It hasn't been analyzed what happens if that transformer is deliberately sending the wrong voltage.
Right.
Okay.
Right.
Now, and the Chinese are monitoring this. I mean, it's not like they're guessing when is going to be the right time or what. I mean,
Well, the thing when we were talking that I was I guess somewhat taken back on wasn't so much that we were buying transformers from the Chinese, was that we actually detected and identified backdoors, and the type of backdoors. I used to talk about something in the financial services industry where they had a cafeteria where they had candy machines, a whole bunch of them, all right, lined up against the wall. People used to go there, take a break and stuff like that, buy coffee, buy candy, snacks and stuff like that. Well, each one of those machines was phoning home.
yes.
All right. And any information that was exfiltrated out of the financial systems onto a USB plugged into the machines could then be sent to whomever.
Yes.
All right. So now, and that was a network issue at the time. So now what we're talking about are these Jugunda transformers. All right. And the Chinese have not just a network access. They have it's like keeping the vault, the door to the vault at a bank wide open at night. All right. You don't have to go through the front door. They've got the whole damn thing wide open. Anybody can just walk in. And I think that's the issue that a lot of people have to come to the realization of, that we bought machines that are cheaper, okay, but the vulnerability is not a network vulnerability. It's the Chinese still own the machine, even though you paid for it.
That's
Did
exactly
I get
right.
that? Did I get that correct?
You're exactly right. And here's the other thing too, that's such a problem. The way I believe that you would know whether this is being exploited is being able to know, are the signals, voltage, current, temperature, etc., that are being sent to these pieces of equipment within a transformer, are they coming from the sensors within the transformer, or are they coming from somewhere else? Well, it turns out those sensors are out of scope for NERC SIP. They're excluded. By the way, that's what's explicitly included in 13920.
Right. Right.
So the issue is, if there is technology, and I'm not going to name any names, but recently the Israeli Water Authority selected a vendor to monitor the water systems in Israel. It was not to monitor the networks. It was to monitor the sensors.
Yeah, the control system.
The control system sensors.
Yep.
If you do that, you can't stop the Chinese from doing what they're doing. They built it. But you can know whether the data is coming from within the transformer or not.
Yeah, so I guess it's like a lot of other things, Joe, and correct me if I'm wrong here, but at least you would know there was truth in reporting.
Exactly. And so the other thing is it gives you the ability to come up with pretty simple technology that if the signal isn't coming from the sensor inside, block the signal.
Right,
Okay.
right.
The way our equipment is designed, you hear all about zero trust. It's in the executive order, all the rest.
Yep.
Where we are in that transformer is 100% trust. It is
Right.
not zero trust.
Yeah, well, it's a very, very serious issue. Do you have any numbers on the number of transformers that we may have in New York?
So far, the only thing we've found, from one of the Chinese vendors, we know there are 5 transformers in New York. That's from one Chinese transformer. That's from their marketing. Okay.
Right.
We also have the transformer at the Bayonne Energy Center, which is not New York, it's New Jersey, but that's what feeds New York.
Right, right.
Okay. Now, there may also be Chinese transformers at other interties feeding New York.
Like up in Niagara and in those
Well,
areas.
I'm saying, maybe, coming down from Montreal or wherever. Okay.
Okay. Yep.
Okay. One of the things we found, to the best of my recollection, is there were Chinese transformers in Quebec.
I want to keep this out of the political realm, but I wouldn't doubt that. Let me just say that. I've seen some things about the Canadian government and the Chinese government that give me great concern. So I could understand what you're saying.
No, it's more than that. The complaint that was filed with FERC dealing with the Chinese transformers. My friend, colleague who submitted it was able to get 158 bills of lading of the Chinese equipment. This is actual bills of lading. So what I told you, I believe there is in Quebec, that's from bills of lading.
Right.
Okay.
Yeah.
This is, they bought them.
Yeah.
Okay.
Delivery receipts.
Yes, this is the delivery receipts. And this is, when you ask how widespread, New York, New Jersey, North Carolina, Texas, Oklahoma, Nevada, California, Oregon, Washington, Iowa, Nebraska. This is from the bills of lading.
Oh.
So the point being, the reason this was filed, the complaint was filed, was because my friend was able to get those. So this has nothing to do with politics. And by the way, we're not talking just transformers.
No, it's a whole laundry list of items.
Yes.
That they're manufacturing, we're importing, and they've got backdoor entry into it.
They potentially do. That, what we know is, we know of 2. Now, you also know the Huawei and CTE chips have backdoors.
Oh, yeah.
In fact, FERC and NERC put out a report on that.
Right.
That's ironic. They put a report out, they're not doing this. You know that the Lenovo PCs have had those backdoor keystroke loggers.
Right. Right.
So the point being, we're not talking about anything that's particularly new. The only thing, in a sense, that's new is where this stuff is there's no data to steal.
Well, I guess, well, that is a very important point, because we're all, kind of tuned into the network and software, and cloud environment and all of that, and all of the foibles that go along with that. But we're not used to dealing with control systems. All right, and that's where the sweet spot in this is. Now we're figuring maybe 5 or 10 machines in New York that we are aware of, or connecting to the New York grid or powering the New York community. And we're figuring what, around 300 machines nationally so far
So far that we know of.
that we know of.
Again, what we're doing also, my friend, when he did this, he was doing it in a funny sense on his own. So he was only able to do what he was able to get access to for free, the
Right.
databases.
Right.
So this
I
is
understand.
really primarily between 2018 and 2020. So he wasn't going backwards beyond that. It would have cost him,
Yeah. Yeah.
So that's 158 or so bills of lading between 2018 and 2020.
So in so to speak, as almost a wrap, well, it is a wrap from here, but on a wrap for this, we have a presidential emergency executive order that gets put out a couple of years ago. And that's 13/9/20.
920.
Yeah, that goes out. All right. It specifically addresses the control systems and tightens the standard. All right. And it actually talks about the control systems,
Yes.
and not the network security,
Correct.
which is the beauty of the order. It lowers the voltage, all right, which would mean that it would include more of these control systems, so we
Yes.
can monitor and make sure that we're what is the word we write down? Resilient,
Yes.
right? And we have a new administration that comes in. They suspend the order,
Yes.
and now it would seem, and I'll use the word, we're like in free fall. All right, because hopefully maybe with us talking about this, we can bring attention to it and bring awareness, which is what we've always been doing, bringing security awareness. And it means different things to different industries. And that's something that I've been saying probably for about 20 years now, almost. All right. Bringing awareness into the industry. And we have a subject matter expert, Joe Weiss, to thank for that. And I certainly appreciate your time today, Joe. And we hope to hear more as we go on. And I would like to follow up with you in the future with the NERC standards, because that's another thing which you hit on during our talk here, that I'm not gonna summarize that, because you put it out there and you're the expert here, that these standards really have to be paid attention to. All right, and maybe other people in the SCADA and control systems arena will take a look at 13/9/20 and say, well, you know what? Just because it was suspended, it doesn't mean that it's not something we shouldn't be paying attention to. All right, and certainly looking at the sensor technology that's out there, paying attention to that on our control systems. All right. And making sure that the reporting that's coming to us is genuine and unique from the sensor itself, and not being subordinated through some nefarious backdoor that China or maybe some other entity has built into the system. So thank you, Joe. Appreciate it. Have a good day, and we hope to hear more from you in the future.
So thank you for the opportunity.
You're welcome.